In our next example, we're going to throw the object downward at an angle below the horizontal from a height of 50 meters. Again, the question is how far will it go before it hits the ground? And again, before you start the problem, you really should find the x and y components of your velocity. So there's the x component, there's the y component. V initial in the x direction is going to be V initial times the cosine of the angle. And V initial in the y direction is going to be V initial times the sine of the angle. So let's plug those numbers in. So this is equal to 20 meters per second times the cosine of 30 degrees. Okay, so that is equal to 20 meters per second times the sine of 30 degrees. Now the sine of 30 degrees, of course, is 1/2, so 1/2 times 20 is 10 meters per second. And over here, the cosine of 30 degrees is 0.866, so we multiply, that would be equal to 17.3 meters per second. All right, now that we have the initial velocity components in the x and y direction, we can now find time in the air. So time in the air, again, is only dependent on the vertical motion, so we only are worried about or concerned about the initial velocity in the y direction. We use this equation, y equals y sub naught plus v sub naught in the y direction times time, so that's this velocity right here, plus 1/2 gt squared. All right, now when we plug these numbers in, final height 0, initial height 50, initial velocity in the y direction. Now notice that this is in a negative direction, so therefore that becomes a minus 10 meters per second squared. Or I should say 10 meters per second, we're not accelerating. And then here this would be a minus 4.9, and that is meters per second squared. All right, so again we have a quadratic equation. We want to rearrange the terms to have the t squared in the front, and we want to multiply everything by -1, both sides of course, to rearrange the sign. So we have 0 equals 4.9 t squared plus 10t minus 50. And now we can go ahead and plug that into the quadratic formula, where we can say that t is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a, realizing that this coefficient is a, this coefficient is b, and this coefficient is c. So we can go ahead and plug those numbers in. So we have t is equal to minus b. Let's see, we have a plus 10, that becomes a minus 10 plus or minus the square root of b squared, which is 100. Minus 4 times a, which is 4.9, times c, which is minus 50. And divide the whole thing by 2a, which is 9.8. So we have 4 times 4.9 times 50 plus 100. Take the square root of that. And so we have t is equal to minus 10 plus or minus 32.86 divided by 9.8. If you've looked at the previous video, you realize you get the exact same result with the only difference that this is a minus 10 instead of plus 10. Plus 10 because there the projectile was shot upward at an angle of 30 degrees. Here it's shot downward at an angle of 30 degrees. That's where the minus comes from. So now when we plug these numbers in, using the positive value here first and divide that by 9.8, we get an answer of 2.33 seconds. Or, if we use the negative possibility, we get minus 10 minus 32.86. That's 42.86 divided by 9.8. So we get a minus 4.37. So you may say, well, that doesn't make a lot of sense. How can you have a negative answer in time? Well, what happens is, if you were to throw the projectile from the ground upward so that it goes up to a particular height, turns around, comes back down at this particular angle with that initial velocity right here, it would take 4.37 seconds from here to reach that point. So that's kind of the imaginary negative portion of this problem, which we promptly ignore. We just have to realize, oh, that's where that came from, but of course we're not going to consider that. There's our true answer for time in the air. And now our next attempt here would be to find the distance. For that, we use the equation x equals the initial velocity in the x direction times the time in the air. Initial velocity in the x direction right here, 17.3 meters per second. Time, we got to be 2.33 seconds. And then for the distance, so 2.33 times 17.3 equals 40 meters. And that's the answer. So again, the approach is exactly the same. We first find the x and y components of the initial velocity. We then find the time in the air using this equation. Once we have the time, we plug it into this equation to find distance. And that's how you do that problem.